This is a review of Chapter 4. Chapter 4 introduces the tissue level of organization. There are 4 types of tissues in the body: epithelial, connective, muscle, and neural. We will discuss all 4 types of tissues in this review. Epithelial tissue has specific characteristics such as cellularity, where cells are hooked together, and polarity, where each cell has a top and a bottom. Epithelial tissue has attachment to the basement membrane, is avascular because it has no blood vessels, and is able to regenerate or produce more cells. Epithelial tissue is classified based on the shape of the cells and the number of layers of cells. Simple squamous has 1 layer of flat cells and is used in places where absorption and diffusion must occur easily, such as the blood vessel lining, the lining of the heart, and the alveoli of the lungs. Stratified squamous has many layers of flat cells and is used in places where durability is required, such as the skin and the lining of the mouth, the rectum, and the vagina. Simple cuboidal has 1 layer of square cells and is found in the tubules of the kidney where absorption and secretion must take place. Stratified cuboidal has more than 1 layer of square cells and is found in sweat ducts and mammary ducts where secretion occurs. Transitional epithelium has cells with many different shapes that change appearance as the tissue is stretched, such as the urinary bladder. Simple columnar epithelium has 1 layer of rectangular cells and is found in the intestines, where absorption and secretion takes place. Stratified columnar epithelium has several layers of rectangular cells and is used for protection in the throat, the anus, and the ducts of the salivary glands. Pseudostratified columnar epithelium appears as columnar because the nuclei are at different heights in the cell. Pseudostratified columnar epithelium is found in the respiratory system. These cells have cilia that move mucus and particles across the cell surface. Glands are epithelia that secrete substances. Endocrine glands release hormones into the interstitial fluid without the use of ducts. We'll talk about the endocrine system in Chapter 18. Exocrine glands produce secretions onto the epithelial surfaces through ducts. Exocrine glands have 3 modes of secretion: merocrine glands, apocrine glands, and holocrine glands. Merocrine secretions occur through exocytosis. Merocrine secretions come from sweat glands. Apocrine secretions are released as the cell sheds its cytoplasm. Apocrine secretions come from the mammary glands and the glands in the groin and the axillary regions. Holocrine secretions are released as the cell bursts, killing the cell. Sebaceous glands perform holocrine secretions. Secretions can be serous, mucus, or mixed secretions. Serous secretions are watery. Mucus secretions are mucin that mixes with water to create mucus. Mixed secretions are a mixture of both serous and mucus secretions. Connective tissue is the second type of tissue. Connective tissue is deeper in the body. There are 3 components to all connective tissues: specialized cells, protein fibers, and ground substance. The ground substance and the protein fibers make up the matrix of the cell. Know the characteristics of these 3 things in each tissue. The 3 types of connective tissue are connective tissue proper, which connects and protects, fluid connective tissue that transports, and supporting connective tissue that gives structural strength. There are several different cells in connective tissue proper. Know the functions of each of these. Fibroblasts create the protein fibers, fibrocytes maintain the fibers, adipocytes store fat, macrophages eat pathogens and damaged cells, mast cells release histamine and heparin in response to injury or infection to stimulate inflammation. Lymphocytes are white blood cells that develop into plasma cells that produce antibodies. Microphages respond when macrophages increase in numbers. They are also phagocytic. Melanocytes synthesize and store melanin. There are 3 types of protein fibers found in connective tissue proper: collagen, reticular, and elastic. Collagen fibers are long and straight, strong and flexible, and resist forces from one direction like a tendon or a ligament does. Reticular fibers are also found in connective tissue proper. These are woven and are strong and flexible and resist forces from many directions, much like the sheath around an organ does. And the elastic fibers of connective tissue proper are branched and wavy, can stretch and return to their original length like the elastic ligaments of the vertebrae return to their original length after you bend your back. The ground substance in connective tissue proper is clear, colorless, and viscous or thick. It fills the spaces in between the cells and fibers and slows the movement of pathogens like bacteria. Connective tissue proper includes loose and dense connective tissues. Loose connective tissue has more ground substance and fewer fibers. Dense connective tissues have more fibers and fewer ground substance. Loose connective tissues include areolar, adipose, and reticular tissues. Areolar tissue is the most common connective tissue proper. All cell types are found in areolar tissue. All fibers are also found in areolar tissue, though most of its fibers are elastic. It is the least specialized of the loose connective tissue. It is found under the skin where it holds a lot of blood vessels. Adipose tissue contains many fat cells called adipocytes. They expand to store fat and they shrink as cells are released, but they don't divide in adults. Adipose tissue is found below the skin and also around the organs. Reticular tissues are found in organs like the spleen, liver, lymph nodes, and bone marrow. Their cells, called reticular cells, provide the support for these organs. Dense connective tissues include dense regular, dense irregular, and elastic tissues. Dense regular connective tissues have tightly packed parallel collagen fibers that are found in tendons, ligaments, and aponeuroses, or broad flat tendons. Dense irregular connective tissues have many interwoven collagen fibers. Examples of dense irregular tissues are the perichondrium, which is connective tissue around cartilages, and periosteum, which is connective tissue around bones. Dense irregular tissues are also found layered in the dermis of the skin. Elastic tissue is made of elastic fibers and is found in the elastic ligaments of the spine. Fluid connective tissues include blood and lymph. The specialized cells of fluid connective tissue are the formed elements that include the red blood cells, called erythrocytes, the white blood cells, called leukocytes, and the platelets, called thrombocytes. The ground substance of fluid connective tissues is very watery. It has a different name depending on its location. In the blood it's called plasma, in the tissues it's called interstitial fluid, and in the lymph vessels it's called lymph. This fluid diffuses from the plasma of the blood into the interstitial fluid, then into the lymph, and finally back into the blood. During this movement of fluid, the fluid and its components are filtered and cleaned up, and its ion concentration is regulated. The specialized cells are different in each of these fluids. The red blood cells are only found in blood and are very numerous. They transport oxygen and carbon dioxide. The white blood cells are found in the blood and they help to defend the body against infection and disease. They include the monocytes, the lymphocytes, the eosinophils, the neutrophils, and the basophils. All of these are found in the blood and the lymphocytes are found in the lymph. None of these cells are found in the interstitial fluids. The platelets are found only in the blood and they help with blood clotting. Supporting connective tissues support soft tissues and carry the body weight. These include cartilage and bone. Cartilage has a gel-type ground substance. Bone has a calcified ground substance. The cells in cartilage are called chondrocytes. The cells in bone are called osteocytes. Both chondrocytes and osteocytes are found in lacunae, or in chambers within the matrix of the tissue. Cartilage is surrounded by the dense tissue called the perichondrium. Bone is surrounded by the dense tissue called periosteum. Cartilage can be hyaline cartilage, elastic cartilage, or fibrocartilage. Hyaline cartilage is found at the ends of long bones, in the trachea, and in the sternum. Elastic cartilage bends easily and is found in the external ear and the epiglottis. Fibrocartilage limits movement and prevents bone-to-bone contact. It is found padding the knees, between the pubic bones, and as intervertebral discs between the vertebrae of the spine. Bone can be compact or spongy. It is strong due to the calcified matrix, yet flexible due to the collagen fibers. In compact bone, the cells and matrix are arranged in circles around a central canal as a structure called an osteon. Membranes are tissues found in the body that contain both epithelial and connective tissues. Know the four membranes and where they are located. Mucous membranes are found lining passageways that have external connections, such as the digestive, respiratory, urinary, and reproductive tract. The surfaces of these passageways are kept moist by the cells of the membrane. Serous membranes line cavities that are not open to the outside, such as the pleural, pericardial, and peritoneal cavities. They have two layers, with serous fluid in between the two layers, which helps reduce friction of the organs within the cavities. The cutaneous membrane is thick and waterproof and is basically like skin. The synovial membranes line the joints and produce synovial fluid to lubricate the joints. Fascia is a connective tissue that layers and wraps organs. Muscle tissue is specialized for contraction and produces all body movements. There are three types of muscle tissue: skeletal muscle tissue, cardiac muscle tissue, and smooth muscle tissue. Skeletal muscle is attached to the skeleton and associated cartilages and is responsible for body movement. Cardiac muscle is found only in the heart and is responsible for heart contractions. Smooth muscle tissue is found in hollow organs like the urinary bladder and the intestines. Skeletal muscle has cells that are long and straight and striated or striped. They are voluntary, which means they must be controlled by the nervous system consciously or unconsciously, and they are multinucleated, which means they have more than one nucleus. Cardiac muscle has cells that are branched and connected at intercalated discs. Cardiac muscle tissue is striated, involuntary, and mononucleated. Smooth muscle has cells that are short and spindle-shaped and are non-striated, involuntary, and mononucleated. Neural tissue is also called nervous tissue. It is specialized for conducting electrical impulses. It is concentrated in the central nervous system, or the brain and spinal cord, but also found in peripheral nerves in the peripheral nervous system. Neurons and neuroglia are the specialized cells of neural tissue. Neurons perform electrical communication, and neuroglia support them by repairing and supplying nutrients to the neurons. The neuron has a cell body, dendrites, and an axon. Tissue injury occurs with mechanical trauma or infection. The body's first response is inflammation. Signs of inflammation include swelling, redness, heat, pain, and loss of function. Inflammation is the release of chemicals into the surrounding interstitial fluid to destroy injured cells and attack pathogens. Mast cells release histamine, heparin, and prostaglandins that increase blood circulation to the area, causing warmth and redness, but also bringing nutrients and oxygen and removing wastes. Phagocytic white blood cells clean up the debris. The second response of the body is regeneration. Regeneration is when the injury or infection is cleaned up and the healing begins. In regeneration, fibrocytes move into the area and lay down collagen fibers to bind the area together and cause scar tissue. Then new cells migrate into the area or are produced by stem cells. Some tissues, like epithelia, regenerate well. Some, like cardiac cells and neurons, don't regenerate or regenerate very poorly. This ends Chapter 4 review.